right, ladies and gentlemen, we're going to do a little jumping around here, and we're going to take a look at lesson 7.1. We're going to study chapter 7 here. Chapter 7 has to deal with what are called similar figures and similar triangles. And so what we want to do is kick it off by looking at ratios and proportions. This is going to be part of what we use in studying similar figures. But today we're just going to be basically a nice algebra review. All right, so here's our vocabulary. A ratio is a comparison of numbers using division. So we look at it as A over B. It's basically looking at fractions. And so then a proportion is two equal ratios. So you'd say A over B is equal to C over D. So we know that something like 2/4 is equal to 1/2. That's a proportion. We are going to see the words means and extremes a little bit later on in the lesson. The means are B and C in the proportion. The extremes are A and D. Truly, it doesn't matter which one you call the means and extremes. What we're going to do is fall back on how we learn to solve proportions, and that's by cross multiplying. B times C, the means, and then D times A, the extremes. All right, so let's take a look at what we have here. We want to simplify ratios. We have 60 centimeters to 200 centimeters, so we can write it with a colon like that, or 3 feet over 18 inches. So what we're going to do is take this ratio separated by the colon and write it as a fraction, 60 centimeters over 200 centimeters. We're then going to divide the number in the numerator and the denominator by their greatest common factor of 20. 60 centimeters over 200 centimeters. If we go and divide 60 divided by 20 and 200 divided by 20, that's going to equal 3 over 10. And then we want to label those, so this is 3 centimeters over 10 centimeters. For B, it's already as a fraction, but we need to be careful. We need to make sure that the quantities in the numerator and denominator are written in the same units. So right now we have 3 feet and 18 inches, not the same units. So what we're going to do is we're going to remember that 12 inches is 1 foot. So we're going to do some changing there. So if we take a look at that, they have 3 over 18 inches. What we're going to have to do is multiply that 3 by 12. And so then what that's going to give me is 36 inches over 18 inches. The common factor there for 36 and 18 is 18. And so we're going to take 36 divided by 18 and 18 divided by 18. When we do that, we get 2 to 1. And so we're going to use the units. We changed everything to inches. So it's 2 inches to 1 inch is our ratio. Because we're dealing with ratios, we're going to keep it as the fraction 2 over 1. All right, now what we want to do is use the ratios that we have. So in the diagram, AB to BC is a 4 to 1 ratio. And we know that AC, the entire length of that segment, is 30. We want to find the two smaller segments, AB and BC. We're going to let X equal BC. We're always going to label our smaller segment with X. And so because this is 4 to 1, 4 goes to the AB and 1 goes to BC. So that's why X is equal to BC. They had that on the diagram. And so because that ratio is 4 to 1, we know that AB is 4 times that, so 4X. If it was a 2 to 1 ratio, it would be 2X. We're now going to go back and pull and use the things that we learned earlier in the year. We know that AB plus BC equals AC. That's our segment addition. The smaller segment AB plus the smaller segment BC equals that total amount. Now we want to substitute what we know. Well, we labeled AB with 4X in the diagram. We labeled BC with X in the diagram. And we know that AC from this top diagram is 30. So that equals 30. We're going to add our like terms. This is 5X is equal to 30. And then we're going to divide each side by 5. Once I do that, I get x is equal to 6. Now I need to make sure I can find AB and BC. We substitute our value for x. AB, when we look back at our diagram, was 4x. So since AB was 4x, that's going to be 4 times 6, which is 24. BC was just x in our diagram, so BC equals 6. So my answers are AB is 24 units and BC is 6 units. All right, we're going to use ratios again at what we have. So we can word these, we could do examples all day long. You will get a chance to do some practicing on your own. So the perimeter of a rectangle is 80 feet. The ratio of the length to the width is 7 to 3. Find the length and the width. So the ratio of the length to the width is 7 to 3. And if we look, the book has a diagram in here. We can let the length equal 7x, and we can let the width equal 3x. All right, so now we need to draw the rectangle at the right and label the sides. So we need to draw this rectangle. And I know the length L is 7x, so I'm going to put my 7x down here. And my width W is 3x. So this should be the diagram that you're drawing in there. They left us room to do that. We're now going to use the formula for perimeter. Why? Well, because that's the only information we have. Back here at the beginning of the problem, they told me the rectangle has a perimeter of 80 feet. So my formula for perimeter is 2 lengths plus 2 widths. That's what it means. We're adding up the 4 sides. So that means 2 times 7x, 2 times the length, plus 2 times 3x, 2 times the width. So this is going to be 14x when we multiply, and 6x. We need to add like terms, which is 20x. And then we're going to have to divide each side by 20. And we're going to get x is equal to 4. We need to find the length and the width. So now remember, the length is 7x, so L equals 7x, which is 7 times 4, which is 28, and that's going to be feet because my perimeter was in feet. My width is 3x, which is 3 times 4, which would be 12 feet. So my length is 28 feet, and my width is 12 feet. All right? So what we're learning here is that to take that ratio and put x's with each of those measurements. So the 4 to 1 ratio was 4x and 1x. The 7 to 3 ratio was 7x and 3x. And then using that information with what we know. So now you want to check your answer for example 3. So what would that look like? Well, we know the formula for perimeter is 2L plus 2W equals our perimeter. So what you need to do is you need to check and see what you're trying to figure out is, does 2 times the length plus 2 times the width equal the 80 feet that are there? So you're going to substitute in what we solved for L. We said L was 28. We said W was 12. And you're going to check and see if that ends up equaling the 80 feet. This will be a check in class problem, so I'll look at your work. All right, checkpoints. In the diagram, EF to FG, that ratio is 2 to 1. And the whole segment, EG, is 24. Find EF and FG. So what we want to remember, and we talked about this is going to be 2x, so EF is going to be our 2x, and FG is going to be our 1x. And so now with that, you should be able to use your segment addition to solve. So you guys are going to finish this, and then we will check in class. All right. The perimeter of a rectangle is 84 feet. The ratio of the width of the length and the width is 4 to 3. Find the length and the width of the rectangle. So you want to draw a rectangle. Remember, if the ratio of the length to the width, that means this is 4x and this is 3x. You know that the perimeter is 84 feet. We just did this in example 3, so you are going to finish this problem, and we will check those in class. I will call people up during the warm-up to do those, so you guys can compare answers during the warm-up. All right? So now let's take a look at our last couple of examples. We have this cross-product property, which you guys saw in Algebra 1. And it says, in a proportion, the product of the extremes is equal to the product of the means. That's what it is in words. And so what that means is that the extremes, BC, is equal to the product of the means, AD, and they're equal to each other. So what it would mean in symbols is if you have this proportion, then BC, B times C, is equal to A times D. That's all it is. So let's take a look at our example. So we went to solve this proportion. Well, what's our solution going to look like? Well, we're going to start off by just copying this original proportion down of 5 over 3 is equal to y plus 2 over 6. When it says solve the proportion, what they're really telling you to do is solve for y. You're trying to figure out what y value would make that solution true. Now, or would make this proportion true. Now, some of you are going to have some mental math strategies, and I'm going to love to hear about those in class. But what we can do is use this cross product property, which means I can do 5 times 6, and I can do 3 times y plus 2. Notice we're putting in everything in parentheses so that we can remember to multiply. So we're going to do 5 times 6 is 30. But we also want to remember that we're distributing here. So we're going to do 3 times y, which is 3y, and then 3 times 2, which is going to give me this plus 6. I have to subtract 6 from each side to start isolating for y. So I get 24 is equal to 3y, and then I'm going to divide each side by 3. So I get 8 is equal to y for that. You can check that answer by looking at 5 over 3 is equal to 8 plus 2 over 6. If we look at those fractions, we have 5/3 is equal to 8 plus 2 is 10 over 6. When you look at those are the same ratio. They are equal to each other, so I know that y is equaling 8 is the correct answer. You guys had 3 of these to do. These are going to be your warm-up in class. So you can do these now, or we can do those during the warm-up in class and simply compare answers.